Hi friends, in the last video we learned the force and motion, Newton's second law P equal mf established, and the law of conservation of linear momentum, principle of physical independence of force. In the previous video we learned this, and also the law of conservation of linear momentum from Newton's third law or from Newton's third law to the law of conservation of linear momentum. Now we are going to learn another one important part. What happens if we apply the force on a body? If we apply force on a body, let us consider in case of the rigid body. Here also only we discuss about the rigid body when the force is applied. Let us consider there will be a plane, AB is the plane. Now a block is here. This is the block is here. The position of the block, let this is be M. M is the position of the block, and when we push the block, then what happen? We push the block by a force F. F is the force and we push it. Then we see that there are two possibilities. Either if the force is sufficient, it causes some displacement. The point of application of force displaces from the position M to a certain point on the plane AB, or it will not displace. So if the block displaced from the position M, now the block is here. Now the block is here. The position of the block, let this is be N, from M to N. So there will be a displacement. Let this is be D. D be the displacement, that is Mn equal displacement. Let this is be D. As we said that the displacement, that means in a particular direction. That is considered in a particular direction. Then we say that this force F does some work. This force F does some work. When we lift the object, let this is be the duster. Now the duster is in my hand. Now when it is raised to a certain height, then what happens? Some amount of work is said to be done. Some amount of work is said to be done. Similarly, now the duster is here. When it is dropped from this height to the ground, also some amount of work is said to be done. That means, how can we measure this? So when we say that some force is applied on a body and the point of application of force suffers a displacement, then we say that some work is said to be done. Here, mathematically, the work done, this work is the measurement of force into displacement. This is force into displacement. This is force into displacement. If we consider this only by notation, here I mention this only by notation without any other facts, then we write this F into D, force into D, that is F for force, D for displacement. Mathematically, what happened in the mathematical representation of it? When we apply force on a body to move the body from one position to the another, then what happened? Let this is be the body. Now we pull the body. Then the force is applied in a particular direction. Force F is the vector. It is applied in a particular direction. So it has the two components. This is the one. This one is the horizontal component. This one is the horizontal component, and it acts with the theta angle, that is the Fx. Another one is the vertical component, that is Fy. Due to the component Fx, the body, the block suffers displacement on this plane. This is the plane. The block suffers displacement on this plane. If the block suffers displacement from the point M now to the point N, this is the Mn, from the point M to the N, then we say that some amount of work has to be done, and mathematically that can be measured as W equal the force here F cos theta is very effective for the displacement of the block, because the Fy component counterbalance with the weight of the block, and this is F cos theta into the displacement. If we consider this, that will be F d cos theta. When we consider that F is a vector quantity and also D is the vector quantity. When we consider the vector quantity F and D, mathematically we can write this as F vector dot product, the scalar product of it, F D cos theta, where F is the vector force, D is the displacement, another vector, F dot D, that is F D cos theta. Then the result work done W, this will be a scalar quantity. So W is the work done, which is a scalar quantity formed by the product of two vectors, force and displacement. Okay, this is the mathematical form of the work done. But this work done may be of different types, because when we drop a body from the certain height, just previously I dropped duster from my hand, so some amount of work is said to be done. Also, when the body is raised to a certain height from the ground, here also the some amount of work is said to be done, but these are not same. So types of work, there are different types of work, there are types of work, different types of works are here. Types of work, different types of work are here. When the point of application of force, now the force acts in this direction, here in this direction, when we push the body, when we pull the body, then also the body displaces in the same direction. The force and the displacement, point of application, displacement of the point of application of force are in the same direction, are in the same direction. Then what happened? Then we say that this is called positive work or work done by the force. So first one is the work done by the force. This is work done by the force, work done by the force, which is also called, this is also called another work done, that is positive work plus work, positive work done. That means the force, the point of displacement of the point of application of force takes place in the direction of force applied. When you push the block, the direction of force in the same direction, also the body suffers displacement in the same direction. Or when you drop, when drop a body from a certain height, that will be the W equals to mg, that is the direction of force, also the displacement of the body are in the same direction. So here the weight of the body W equals to mg and displacement takes place in the same direction, and mathematically W equal FD cos theta, here FD cos theta, the theta equal 0 degree, theta equal 0 degree, here theta equal 0 degree, because the point of application of force and the displacement are in the same direction, are in the same line, that is the direction of F, and also that is the direction of the displacement, that is F and that is D. So that is 0 degree. This is positive work with the example. Another one type, that is called the work done against the force, work done against the force, against the force, or which is also called the negative work, negative work. What happened in this case? In this case, now a body is on the ground, it is raised to a certain height. Then what happened? When a body is on the ground, now the block is here or a ball is here, the weight W equals to mg acts in this direction. Now the body is raised to a certain height, to a certain height. So the displacement in the opposite direction, the displacement of the point of application of force and the, this is the F and the force are not in the same direction, they are in the opposite direction. In this case, the theta equal, the angle between the force and the displacement, theta, this is equal 180 degree. This is equal 180 degree. In case of the positive work, mathematically we get that W equal cos 0 degree. If we put this, the value will be only FD, because cos 0 degree 1. Since cos 0 degree equal 1, cos 0 degree, this is equal 1. Here also theta, if we replace the value of this W equal FD cos theta, then we get W equal FD cos theta, FD cos 180 degree, cos 180 degree equal minus 1, minus cos 0 degree, that is equal minus 1, cos theta equal cos 180 degree, this is equal minus 1. So this is negative work, this is negative work. Another one important question is also here, that is called the no work force. We apply force, but the work done remains 0. In the next video, we learn the rest part of it, the unit of the work done, the power, unit of power, relation between them, the dimension, no workforce, what are the conditions of no workforce. In this video, up to this, okay?